Hello everyone, welcome back to my channel. Today we are going to have a very fun lab, uh, which is kind of a kind of an uncommon scenario that many even network engineers don't work with this kind of scenario day to day. But it's just good to know how this kind of scenarios like exceptional IPsec VPN tunnel between different vendors would build up. Uh, so today we are going to talk about F5 BIGIP IPsec tunnel to Cisco IOS in GNS3 lab environment. So as you know, BIGIP F5 BIGIP after uh, OS 13, I guess they supported IPsec, so you can terminate not only SSL VPN for client to site VPN, you can also terminate IPsec VPN tunnels to your F5 BIGIP and also manipulate the traffic with the LTM and ASM and have your one F5 BIGIP as your VPN termination device. It doesn't matter if it's on premise or it's a physical device, or it's a virtual edition BIGIP, or even in public cloud. I have done the same scenario in Microsoft Azure, so you can leverage this cool feature in order to have IPsec VPN between two devices, including F5 BIGIP. Now, let's jump into the lab and let's start our cool lab scenario. So as you can see, I have pre-configured the whole lab. So what we have here from right to left, I have a Cisco IOS 15, which is a iOS V 15. And this one is simulating the remote Pier. Is one of our remote sites that it has a loopback address 192.168.10.1/24, and it's connected to a kind of a cloud, which is in fact another Cisco iOS v15, but it's acting like a uh, internet. It's simulating internet for us. And then it's connected from gigabit 00 to our F5 BIGIP LTM module, LTM Virtual Edition 13.1. And for that, from my BIGIP, I have one interface, which is 1.1 here, which is a mistake by F5. It's in fact is 0. It's management IP address. It's management interface, which is connected to a cloud, this kind of cloud that you can insert from GNS3, that I just changed the symbol to a laptop, which is a loopback interface. If I want to show you here, configure, it's mapped to Ethernet 4. It's a Microsoft loopback interface, which is connected to my own laptop that I'm recording this video, and I have assigned an IP address to it, and I can log in to the via the management interface to the F5 BIGIP portal and also CLI. And on the other hand, another interface which is connected to one of my VM Windows 7, which is running on a virtual box, Oracle virtual box here, as you can see. If I do cmd ipconfig, as you can see, it's another subnet 1010.13.1 /24 and 1010.13.200, which is the default gateway, is pointed to IP address of the F5 BIGIP. Now, for many of you, if the question comes up that how we can have F5 BIGIP integrated with GNS3, I would make another video to how to install F5 BIGIP in GNS3, but that's actually straightforward what you have to do. I'm going to list it for you briefly. What you have to do, you have to download the virtual appliance from GNS3 official website. Then you have to also get the virtual edition image from F5 and install it inside the GNS3. Then you have to get the proper licensing. So it's not like FortiGate or iOS that you can have. You can just insert and use the evaluation license whenever you want. You have to register with F5 website officially, and you have to request for licenses. So I requested like 2 months ago for 3 licenses for 90 days evaluation, and I have already applied in another device. So I will show you in another video that how you can do that. Now let's take a look at our devices from right to left, and then we are going to start the configuration. So now this one, Cisco IOS VT2 actually, which is this device for me. Let's see, show IP interface brief, what I have here. So as you can see, gigabit 0070.10.10.1, and I have the loopback interface, which is going to simulate my LAN IP address. So let's take a look here. I'm talking about gigabit 00, which is this one. So then I also have on default route here 000. As you can see, it's pointed to the next hop as 70.10.10.2, which is the IP address of my internet cloud here. So let's jump into the internet cloud, which is another just Cisco router. Let's see what we have here. Show IP interface brief. I have just simply 2 interfaces. One of them is connected to my BIGIP F5, and one of them is connected to my Cisco IOS. And there is no specific route on that because it's just one router in between. You don't need to configure anything on that part. Now let's jump into the F5. So I have already pre-configured the F5. This is the CLI and this is the GUI. I just want to show you that I can. Let me show you actually the CMD of my laptop, ipconfig. I have a couple of virtual interfaces, but this one that I'm going to show you, Ethernet 4, as you can see, this is my loopback IP address, loopback interface, Microsoft loopback, which is linked into GNS3, and it's a bridge between my real world laptop to virtual world in GNS3. And my laptop IP address is 10.10.10.10, and the default gateway is actually the big IP F5. So as you can see, this is 10.10.10.10, and this is 10.10.10.200. So I'm going to log into that HTTPS. So 10.10.10.10.12, 200, sorry. As you can see, this is my F5 inside. This is my F5 inside GNS3, and the configuration is almost blank. So before we start configuring the IPsec tunnel, I would like to show you a couple of pre-configured things. First of all, what I have done from networking configuration point of view, I have defined already 2 VLANs, which is usually the most common scenario in F5 deployment. One external, one internal, and as you can see, it's untagged interfaces. This is important to leave it as untagged. This is better because if you configure them as tagged interface, then you have to configure the proper interfaces on the switch side, on the layer 2 switch, to have chunk, otherwise your traffic will be dropped. But it's just a kind of a logical segmentation between the traffic. So 2 VLANs, external 1.1, internal 1.2, and both of them are untagged VLAN. Now, from IP point of view, I have assigned already the IP addresses. So as you know, in F5, you can't actually assign an IP address to an interface. You assign an IP address to a VLAN, kind of to a VLAN or kind of to a zone, and that's the big difference between F5. So you shouldn't look at F5 big IP appliance as a router that you can have IP address on a single interface, right? So how does it work here is like that I have assigned a self IP address to external to this NIC external self, right? Actually not NIC, but to the external VLAN and also to one VLAN. And because those VLAN are mapped, as you can see here, to different interfaces, so consequently the IP addresses are assigned to those interfaces. Now from routing perspective, I have just one default route. I have added it myself that it's pointed to the IP address. The next hop is the IP address of my internet cloud here, 198.44.44.2 is my cloud here, and 1 is my BIGIP F5. So one point about the one important point about interfaces is that when you this is something that I found out by trial and error, and unfortunately I don't know why it's not documented by F5 or by GNS3. When you configure and when you deploy F5, BIGIP F5 within GNS3, by default, what you get is 1.2, 1.1 to 1.7 interfaces names for your BIGIP F5. But in fact, if I go to statistic, you can see that my management interface is kind of a zero. So the production interface is 1.1 and 1.2 1.1 starts rather than the management. What does it mean is that so here when I connected my BIGIP F5 from 1.1 to my own laptop via the loopback interface, in fact it's not 1.1 because on the GUI we can see that 1.1 is not the management, and in fact 1.1 is the interface which is connected to this switch which goes to the internet. So just a heads up when you want to configure the BIGIP F5 in GNS3. Now we can start gradually configuring our cool IPsec tunnel between the two devices. Before that, we will just verify end-to-end connectivity by pinging the other remote peer. So I'm going to jump into my Cisco router on the right side of my diagram. And here I'm going to ping 198.44.44.1, which is the IP address of my BIGIP F5. And as you can see, the ping is successful. It shows that I have the IP connectivity. Just to be on the safe side, let's do the same with my BIGIP F5. So I'm going to ping 70.10.10.1 if I'm not mistaken. Let's check interface brief. Yes, 70.10.10.1. And as you can see, ping is also successful. So I have IP connectivity between the two devices. Now, let's start the IPsec configuration from the iOS side. So we will start by building up the phase one, global configuration mode, crypto, ISOCAM, policy number, let's say 20. Now, the options I have here, authentication will be preshared key, encryption, I would like to have AES, 128 bits. What else? Diffie-Hellman group, I would like to have 14. And the hash, I would like to have SHA-1. What else? I assigned authentication, encryption, Diffie-Hellman group hash, lifetime. We will leave it as it is. So let's exit from ISOCAM configuration mode and let's check that. Show crypto ISOCAM policy 20. Sorry, policy. So this is my encryption AES. Yes, 128 bits key. That's correct. Secure hash standard, which is SHA-1 preshared key. And as you see, lifetime for phase one For Cisco is 86 400 seconds, which is, I think it's 1 hour, but we will see. Okay, now I would like to configure the preshared key. So crypto ISACamp key, I will call it Cisco with capital C 1234. And address, I just put it any kind of address, doesn't matter. And that's it. So yes, we created our, we define our preshared key. The next step is to create our extended access list. So IP access list extended, we will call it as ACL crypto IP crypto F5, right? Now, permit IP source, I'm going to source my traffic will be 192.168.10.024. So I'm going to say permit IP 192.168.10.0 wildcard mask 000 slash 00, sorry, 0.255. Destination will be, the destination will be the LAN behind the F5 big IP, which is 10.10.10.13, which is connected to my Windows 7 Oracle VM VirtualBox. So I'm going to put 10.10.13.0 slash, okay, wildcard mask 0.0.0.255, and I think we are good to go. Now, this is our access list. The next step is to create our transform set for phase 2 IP crypto IPsec transform set. I will call it my set. Now I'm going to have ESP AES and also ESP SHA HMAC. Now we are going to leave everything else as default, which is tunnel mode. We are not going to do transform mode. Okay, we define the transform set. We define the ISACamp policy. We define the preshared key. We define the ACE extended ACL. Now let's define our Cryptomap. So I would put Cryptomap word. I would say my map F5 and the sequence number, let's say 10, IPsec ISACamp. So let's see what we can do here. I'm going to say description, just put a description, meaningful description, Cryptomap for F5 IPsec. So match address. What was my access list name? So let's do show IP access list. Okay, so match address ACL crypto F5. Copy paste. I also have to define my peer, set peer. My peer will be 70, no, that's myself, 198.44.44.1, if I'm not mistaken. Let's have a quick check here. If I go to network, self IP, yes, 198.44.44.1. That's correct. Now I don't want to have default. What else? Let's see what we have on set. Okay. We set the Pier, set the transform set to my set. And I think that's it. We don't have anything else to do here. We will leave the PFS as disabled. We don't need NAT. Okay, so my Cryptomap is created. Let's check that. Show Cryptomap. I have one Cryptomap called my map F5 sequence 10. The Pier is the IP address of external IP, the IP address of the BIGIP F5 on external VLAN. And this is my access list, which is okay. The lifetime, which is a default, 3,600 seconds. PFS disabled, responder only disabled. Transform set is my set. Okay, everything looks okay. I will just jump into my interface gigabit 00, which is my external interface, right? And I would say Cryptomap. What was the name of my Cryptomap? It was this guy, my map F5. Bang. So ISACAM engine should be ignited somehow, which is true. ISACAM is on now. Our Cisco IOS side is ready. Let's jump into our F5. Now, this is the fun part because on F5 we have to do a couple of things. So what we have to do on F5 part, we have to configure the, just like any other device which is going to initiate IPsec, which is going to build up IPsec tunnel. We have to define phase one, phase two, traffic selectors, which is kind of like a crypto map on iOS. And also, beside that, we have to have some specific configuration on the LTM side, which I will show you, in order to force the F5 to act like a router to forward the naked traffic after the decryption to the back end subnets, to the LAN. So we have to have IP forwarding virtual servers on LTM side. So I will show you that. Okay, so let's go. Let's do that. On IPsec, I will come to, so let's do it from the beginning to the network tab, IPsec, and here the first tab you see, IKE peer list, Internet Key Exchange peer list. Here I'm going to define my phase one. Okay, I'm going to say IPsec 2 iOS P1 phase 1. Remote address will be 70.10.10.1, right? 70.10.10.1, IC version 1, authentication SHA-1, encryption AES. And here's one of the tricky part, that the Diffie-Hellman group is actually perfect forward secrecy PFS on phase one, and it puts the cryptographic terms for that. It doesn't say group one, group two. So you just have to check your list that which group you have assigned, and you have to check the equivalent cryptographic term for that. So uh, we assigned group 14, which is going to be a 2048 bit key. Lifetime, we had, let me check here, show crypto ISACAM policy. Lifetime is 86,400 seconds. 86,400 multiple by 16. It's, oops, 86,400 multiple 16. 1440 minutes. Right? Yes, that's correct. Okay. I wanted to just double check that. Now, authentication method will be preshared key. Our preshared key was Cisco with capital 1234. Cisco 1234. Mode will be the main mode. Natron will solve off. So we will leave everything else as default. DPD delay. Now finish. We will put the finish. Now my phase one is created, as you can see, and the address that remote peer is 70.10.10.1. Now I'm going to define my phase two transform set. So create. Here I would put again IPsec to iOS, IPsec to iOS set. So IP protocol ESP, I'm going to put it at tunnel because I don't remember if we didn't change it. We left it as default in iOS part. Just like check quickly, show crypto IPsec transform set. Yes, this is my set and it's tunnel mode. We'll leave it at tunnel. Tunnel local address is going to be 198 44 44 44 1. Tunnel remote address 70.10.10.1. Authentication for phase 2 was again SHA-1. Encryption was AES 128. No PFS, no IPCOM. Lifetime was, let's check the lifetime. Sure, Cryptomap lifetime was 3,600 seconds. So 3,600 seconds multiplied by 60 will be 60 minutes, 1 hour. Okay, so we have to just put here 60 minutes and finish. Okay, my transport method is created. Now I'm going to go traffic selector list. Now here, the best would be if you create a traffic selector list. It's a kind of a like a F5 language of your Cryptomap, your extended IP access list. So if I want to create, the best would be, because you have different directions, the best would be you create one for inbound, one for outbound. So let's do that. I'm going to put it in advance here. Name would be, um, we can put, let's say F5 to iOS inbound. I'm going to put it, specify order one here. Now source IP will be my LAN source IP, right? 10.10.13, and source port everything. Destination, sorry, it's in mount, so the source IP should be in 192. Yes, because it's talking about the traffic which is hitting me from the iOS side. So the source IP will be 192, 168. Now the destination will be 10.10.13. All ports, protocol, all protocols, and direction will be in. And here, IPsec policy name, I have to assign my transform set here and finish. Now, I have my traffic selector for inbound. As you can see, let's create another for outbound. F5 iOS out. Order specify, let's say 1. Now, the source IP this time will be 10.10.13, which is the LAN site behind my F5. Destination between 192 slash 24. Direction out, and here I also select my transform set. Finish. Now everything looks fine. Now I have one traffic selector for inbound, one traffic selector for outbound. I have my transform set for phase 2. I have my phase 1 IPsec, the ISOCAM tunnel. Now, what we have to do, we have to go to the local traffic manager LTM, and we have to define our virtual servers for inbound and outbound of the traffic, which forces the F5 somehow to act like a router, because as you know, F5 by default is not a router. So because when you are doing load balancing with LTM, the source and destination the source and destination IP address and the IP header will be changed by default when you are doing normal load balancing. No, we don't want that, because maybe we want to do that on the second level, that when the naked traffic is already routed somehow to the destination, then we do the manipulation. But in this case, we don't want to do any manipulation, because we want to just terminate the IPsec tunnel on this F5 and send the traffic to my LAN side, which I have one host, which is my Windows 7. Now, in order to do that, I have to come here to my LTM virtual server and create a new virtual server. I will call it VS. Okay, I already have it. VS IPsec to iOS out. This is for outbound. And I will put for the destination to this, let's say this VS will route, let's say will redirect outbound traffic to IPsec tunnel to iOS. So here's the kicker, and here's the most important part of the game. We have to put the type of the virtual server to forwarding IP. This way I'm forcing my F5 BIGIP to act just like a router, and I'm not going to change anything on the source address translation part to leave the traffic as it is, to leave it intact. So the source address here, we will put 190, 100, we will put 10, 10.13.0/24, which is the LAN subnet of behind my own device, because we are talking about outbound. So this is going to be the source. Destination will be this guy, 192, 168, service port all, and the protocol. If you put TCP, you won't be able to ping and check your tunnel by ping by ICMP. So I will put it all, and protocol profile will be fast layer 4. Now here I'm going to enable this only on, because this is outbound and traffic is coming from internal VLAN. I'm going to enable it on the internal side, internal VLAN. A source address translation, I will put it none and finish. Okay, so this is my virtual server for outbound traffic. Let's create one for inbound. I will put VS, exactly the same. This time I will put in. This virtual server will redirect redirect traffic into IPsec tunnel to iOS. Type IP source address this time will be uh, inbound source IP 192, and this is going to be my own LAN. So this guy, service port all ports, protocol are protocols, and it's going to be enabled because it's inbound. uh, it's gonna hit my external VLAN, and everything else as it is. Finish. Okay, so uh, everything is ready now. We have the tunnel configuration on both sides. Now I should be able to have my tunnel up. Let's see that. So before I initiate any traffic to check the tunnel, I'm going to check here, show ISOCAM, show crypto ISOCAM SA. So I don't have any security association for ISOCAM established to my iOS router. That's correct. Now I'm going to jump into my VM, Windows 7 VM, which is in my LAN behind my BIGIP. And I'm going to ping The loopback IP address on the remote peer on the Cisco iOS, and hopefully my tunnel will come up. Let's hope for the best. 192.168.10.1. Okay, and there we go. We have the tunnel up, and it's working. So in order to just verify that, I on the router I have show crypto isocam ASA, and as you can see, the SA is established. So if I do detail, as you can see, I have my encryption hash, and if I do show crypto IPsec SA, 8 packets going back and forth, and this is so beautiful that I have my IPsec tunnel between my F5 and my iOS, Cisco iOS. Now, I'm going to ping from my router as well. So show IP interface brief, exclude unassigned. Okay, so I'm going to ping 10.10.13.1, I guess. Right? .1, yes. .1 with source loopback 1. And my ping is successful. So repeat 100 times. Now if I do show crypto isocam, show crypto IPsec SA, I have 113 packet going back and forth. So this was that much easy, as you can see. And if I just take a look at my virtual servers here, statistic on my IPsec part, on my F5 part, and I can see the traffic is going back and forth. And my IPsec tunnel is established between F5 and my Cisco iOS. I hope it was informative for you, and thank you for watching.